Good morning. We're going to read Undersea Earthquakes Reveal Sound Warming Info. So let's circle this title, and we know what we are looking at. So we're going to have some kind of article about undersea earthquakes and sound warming. No, this sounds interesting. Let's read this caption. Sound travels at different speeds through cold water than warm water. Scientists are using that information to check the ocean's temperature. Okay, so they're measuring the temperature of the water by how fast the sound goes through. Okay, that sounds interesting. Climate change is a significant change in the climate of the Earth. It happens over a long period of time. It can happen naturally or in response to human activities. For example, the burning of fossil fuels creates gases that trap heat in the atmosphere. Not all of the heat trapped in the atmosphere stays there. About 90% of it goes into the ocean. So it's really important to track the ocean's warming, says Jorn Callies. He's an oceanographer at the California Institute of Technology. An oceanographer is a scientist who studies the ocean. Tracking how the heat affects the ocean is difficult, though. Oceans are so deep and big that scientists can't easily measure their temperatures. This makes it hard to understand long-term changes in temperature. In September 2020, Callies and other scientists reported a new way to check the temperature of the ocean. They used sound from underground earthquakes. The new method would allow scientists to measure temperatures changes across the entire ocean basins. So let's circle this heading. What factors affect the speed of sound? Sound is a form of energy that travels in invisible waves. Sound waves, or vibrations, can travel through solids, liquids, or gases. But the speed of sound is not always the same. For example, sound waves travel much faster in liquid water than they do in air. It is because of how close particles are to each other. In water, particles are more closely packed together. In the air, the particles are spread farther apart. Temperature also affects how fast sound travels. Particles at higher temperatures allow sound waves to travel more quickly. So sound travels faster in warmer water than in cold water. Measuring changes in how fast sound travels in the ocean is useful. That's because the speed of sound is very sensitive to temperature. A small change in the temperature can cause a large change in speed. Say the ocean temperature increased by 1 degree Celsius, 1.8 degrees Fahrenheit, the sound speed changes would roughly be about 4 meters or 13 feet per second. All for that little bit of change in temperature, just 1 degree. So let's get this going. Let's circle the next heading. Using sounds produced by underwater earthquakes. Callies and his team showed that they could use the natural sounds in the ocean to measure temperature. In an underwater earthquake, some vibrations bounce off the seafloor. Those vibrations turned into sound waves. These can be picked up by underwater microphones. They can also be detected by seismometers. These are instruments that measure earthquake tremors. For their study, the scientists looked at data for 2,000 pairs of earthquakes. These earthquakes occurred in the East Indian Ocean between 2005 and 2016. Each earthquake pair happened in the same place but at different times. This allowed the scientists to measure how much the sound waves sped up. What did the scientists find? That sound waves traveled a few tenths of a second faster in more recent quakes. The difference suggests a warming trend of 0.04 degrees Celsius every 10 years. It is about 0.08 degrees Fahrenheit every 10 years. A fraction of degrees may not sound like a lot, but it means the ocean absorbed a huge amount of heat. It takes a lot of heat to change the temperature of a large body of water. Parts of the ocean are almost 3,200 kilometers or 2,000 miles wide and several kilometers deep. Using this approach in the future. Yes, because this sounds like a really good way to measure temperature. So far, the new method shows that the oceans are warming more than scientists thought. Callie says it's not the time to worry about it yet. It could be that the warming is specific to the East Indian Ocean, or it could be happening elsewhere. We just don't have the data yet. All right, now it's your turn. Go to the questions, answer those for me. Thank you.